Hello everyone. Welcome to our showcase of case studies from Persistent's AI research team. Our first case study will focus on NLP and we will show a demo on relevancy classification of unstructured text. Today, huge volumes of valuable business data exist as unstructured text. Extracting knowledge from this data by deriving some structure is a major task under the scope of NLP. In this video, we will discuss a case study, some useful modeling tips and tricks, and benefits associated with relevancy classification. Often, one of the most time-consuming and labor-intensive tasks for subject matter experts is identifying which documents are useful and relevant for their work. For example, identifying which news articles talk about new funding secured by a startup, or announcements via blogs or articles where a company signs a new deal with another company, and so on. Once we identify a relevant article, we can then extract more useful information like deal size, effective date, location, etc. While these tasks look straightforward, they entail manually sifting through a huge number of such documents only to find few articles relevant and then process those documents to extract useful and high-quality information. Also, the slice of most relevant information is usually very less when compared to all the articles and typically lies in the range of 5 to 10% only. This is a perfect setting where a machine learning workflow could automate the entire process and hence help the SMEs save time for day-to-day work. We will demonstrate this relevancy classification via a case study applied to clinical genomics. Clinicogenomics is the study of clinical outcomes with genomic data to understand causal effect of genomic factors. Experts working on clinical genomics usually require curated information for their study. This information could be in the form of research material available in-house or via open information websites like PubMed. In this case study, we want to identify all the articles relevant to expert study of certain types of solid tumors that they are interested in and discard all other information. There are other factors involved in accepting a PubMed article. For example, if the biomarkers are of interest, whether the study involved humans, etc. Although PubMed provides logical filters via medical subject headings, also known as mesh terms, they are limited to only few types. The typical challenges involved are: analyzing articles and identifying relevant papers is manual and time-consuming. The process is not scalable. Domain experts' time is underutilized. Hence, there is a need for automation workflow to classify PubMed articles as accepted or rejected for future study. Architecture. Accepted and rejected articles are fed to a text pre-processing system to extract useful features. A machine learning classifier is trained on this annotated data, and the metrics and results are presented to SME via a web application-based presentation layer. Experts can identify any errors during classification, and those are fed back to the system to complete the loop to avoid future errors. Since the idea of relevancy is hidden inside the articles which only experts can uncover, traditional non-machine learning keyword-based algorithms cannot identify them with high accuracy. We utilize BioBERT model pre-trained on PubMed articles for high-quality vector representations and Spacies text categorizer. Title and abstracts of each article is used for classification. Some tips and tricks. We do not want to lose out on relevant documents even if certain irrelevant documents are included. Hence, the design of the ML classifier should be optimized to increase recall of relevant articles while trading off on precision if required. Since the data is highly skewed and labels are imbalanced, techniques like oversampling relevant and undersampling irrelevant articles can increase the performance of the classifier. Using a domain-specific ontology or dictionary to increase accuracy. If using transformers like BERT, a pre-trained transformer trained on domain-specific vocabulary can provide good results. To demonstrate the workflow, we will be using a web-based application representing an expert screen who wants to check if an article is relevant. We will enter a PubMed article ID. The system will fetch the title, abstract, and other sections of the article and predict the relevancy. In this case, this paper is accepted. So let's see the extracted information from this article. This could also be loaded to a structured target like relational databases. Let's try another PubMed article ID. As one can see, the article involves discussion on leukemia, which is not the topic we are interested in, and hence this article is marked as rejected and will not be included for future processing. So, as we saw via our case study, organizations can save a lot of SME time and effort by automating their typical classification workflow. Since the classification involves latent features, it is difficult for simple non-ML algorithms like keyword matchers to identify relevancy. Further, the ML-based process can have the following benefits: tag-based metadata search application, gist creation mechanism for quick summarization, transform unstructured text to structured data for analysis, and many more. Our case study is applicable to a variety of domains like media and entertainment, corporate financial analysis, biomedical and scientific research, and many others. Hope you enjoyed the video. For more information, please contact us via our website www.persistent.com. Thank you.